we've got a new job, Abby. Have we done F15 X5 before? I don't think we did. Oh, this one, it has the battery light on. And you would just say, when this happens, most of the time it's gonna be the alternator. And you know what? Many misconception I hear. Whenever the battery light comes on, you know what everyone is thinking of? Replacing the 12-volt battery, which is wrong, because the battery light comes on if the 12-volt system is not getting charged, not because the battery it's weak. So let's get on to see what it's all about. Is it an alternator or is something else? Now, what is different on this? It's an electric, it's a hybrid vehicle. And those F series, even for 3 or 5 or X, they no longer have an alternator. And when the battery light comes on, it's usually, most of the time is because the 12-volt system doesn't get charged, but the reason is that it's not getting charged. It is an issue on the high voltage system, because this is a hybrid, and we'll need extra power to get this car started because the battery is weak, very, very weak. And we are planning to drive this in the workshop. Let's have a look what lights are coming on. Hopefully we can still get it running. So, does it still start? Yeah, the battery. So it's charged. It starts eventually. Idle speed is increased, battery discharging, and then we should have the battery not being charged. Now, the car doesn't have an alternator. It has something else. Let's go in the workshop to see what it's all about, because this is not applicable just to X5, applicable to 3 Series, 5 Series. It's gonna be interesting, a one that we haven't filmed before. Hello from OGS Mechanics. I'm George, and here we fix cars, all types of cars, electric, hybrid, combustion engine cars. Have a look around and follow me for interesting repairs translated in videos. We have now partly saved in the workshop, but you know what, I was thinking about it and I would like to hear from you. How often, and whether it happened to you or you heard anyone, having the battery light on the dash and the first call of action was to replace the 12-volt battery, because it's wrong, is a wrong diagnose. The red battery light, it won't come on if the battery is weak. But I heard this so often, even technicians, to be honest, I even heard it from BMW, seeing that battery light on, first point of call to replace the battery, which is wrong. Anyway, we got a car on the ramp. What we're gonna do, we're gonna put a power supply on and we're gonna run a test to see exactly where we're gonna start to fix this car. Now, because we have a low battery, we're gonna put the charger on first of all, set it up to 13.5, so we have stable charge while we're running the diagnose to understand where we're gonna start from. Scanning the high voltage system. Look in here, that's what a loose contact is. So here we are scanning just the control unit on the high voltage side of the vehicle, and straight away there's a fault, an error code that stands up, and this is the one related with the switching contactor contact stuck close. This is basically, what is it?
It's basically cutting off the power from high voltage
Yes.
to go to the rest of the
So
vehicle.
the relays that stop or close the circuit of current flowing out of the battery. On all high voltage vehicles or hybrid, electric or hybrid vehicles, you're going to have this safety box. And our error code is saying that one of those relay is stuck closed. So they should obviously open and close, open and close. And for some reason, it looks like one of them, it is stuck. Checking everything else, nothing really stands out. We have to address this error code first of all before we move to the next one. Now for this particular one, we have to get into the high voltage battery. And before we move forward, I want to check a few more stats about the battery. So in here, we're going to see exactly the condition of the battery, state of health, and if it is balanced, a very important aspect when it comes to batteries. So what we read here, state of charge, which is 22%, it's okay. State of health, 100%. This tells us the battery pack is in quite good condition, and this figure here, it tells us how well the battery is balanced, and it is quite good. What we like to see is around 20-30 millivolts. This is the good value. So knowing that the battery is good, we need to see where is the battery located and to start stripping it. Do you have any idea where it is? At the back. And what is right on this machine is we have module location. So what this diagram tells us, we have 6 modules, and obviously we know that already here. We have 6 modules, and the battery seems to be located in the back of the vehicle. Knowing this is the time to move to the high voltage battery. So we'll disconnect the charger. The 12-volt battery should also be in the boot, and according to the picture, the high voltage battery should be there. So that's where we have to go. Can you turn the ignition off? I'll disconnect the charger. Yep. Let's go in the back of the car. So we know for certain, because we worked before on those X5s, the batteries, 12-volt batteries are here, and the high voltage battery is at the back. Lifting this cover, we already undone this. And then in here, we can see the 12-volt battery, the main one, and the auxiliary one. So we'll disconnect those. And by doing so, we also make safe the high voltage system. Now, whenever you have to work on a high voltage system, you have to disconnect the service connector. BMW vehicles, they don't have a service connector on the high voltage side. It's always a small connection that interrupts a contactor circuit towards a relay. But by disconnecting the batteries, no longer needs to remove the service connector. So we're gonna disconnect the batteries. Didi, if you can start working on that, and then we're gonna strip all this panel because we need to get to the high voltage battery. Now, we haven't taken one apart yet. We just have to see whether we can strip the high voltage battery in situ, because we need to take the top cover off to get to the relay box and then get it checked. So battery is disconnected. Didi, if you can start taking the cover back. Yes, because we need to get access to the top of the battery. All right?
Right.
This is now disconnected. And we can also lift the cover that was held in place by the other cover. And we now have access to the battery. So this is the high voltage battery, obviously lithium ion. What stats do we have here? 351 volts, 26 amps. Okay, we can take this cover off. And the access, it's quite good. Now, what we'll try to do is see whether we can work in here. And looking at it, we have an access panel, and hopefully this is going to be to the safety box. And if that's correct, then we won't be able to take the whole cover. Might be very smart if that's the case. So let's interlock, undo the cable from which one is going to be easier? Probably from here. And then once you're going to take the cable off, we're going to take the panel, the access panel off. So can you prepare the torch that we need? Okay. Perfect. So if you can undo all the bolts that you can do now, apart from this probably last one. So under this connector, in theory, we should not have voltage. However, because we have a sticking relay, we actually might have voltage, which is not good. And can you take the interlock off? Let's see. Oh, need to climb. It's very tricky, isn't it? The interlock, what Didi is trying to remove now, is basically just a bridge that it won't allow the system to operate until this is on. And all the components on the high voltage system, they have those type of bridges, and they are called interlock. So let's see. Does it have to go more? No. Okay, so if we have this out, let's see how we can route this in the best way possible. So hopefully that's good enough. This is the access to the relay, and can you take it? Well, it is access to the relay box. The problem is we are not able to do anything here. Now we are not able to do very much in here because the access is limited. We can see the safety box is this black bit here. So the plan is that we need to stream more. So we'll need to remove those two brackets, and we do need to take the cover off of the battery. So just gonna put the cover on to stay on like this. We're gonna cover the high voltage connector until we stripping all the bars, yeah? Right. Didi, I'll leave it with you, my friend.
Sure.
A bit more stripping needed. We've made room, we've disconnected the top cover from all the bolts, we've got a high voltage detached. Now we are getting close, taking the cover off and reveal the safety box where we have to do our next checks. We try to do everything in situ, so we don't have to take the battery out. The battery fitted in the boot of the car is quite difficult to be taken out, and if we can do this here, we'll save a lot of time because we don't have to take the gas out. I think this battery should also be, is air conditioning cooled. So let's see how we're gonna do this. In here we have to disconnect also the high voltage cables. And I'll show you in a second why. It's a bit of okay. So let's see if we take the cover off. Brilliant. Come this way, Didi. So this, what we've disconnected are the cables that go to the port and the interlock connection. Now here is our battery, 3 packs, 3 modules on top of another 3, which they all balance, nothing wrong with them, and we're not gonna work on them. What we're gonna work on is this bit over here, which is the safety box, the box with relay, which operates, which controls the flow of current in and out the battery. And in here, according to the error code, something is not good. Oh. This one. And this side is done, so we should have disconnected the, yeah, and I need the Torx for the bracket, and we should be able to take the safety box out together with the battery module. All disconnected. Those 2 wires, they have live high voltage. We should be safe enough. Let's put this on in here. This is gonna be, yeah, gonna be perfect. Take that out. It's not easy at all to work with those gloves. Okay, I have 2 more, and I need an extension and probably a magnet to fish those bolts. It's quite deep in there. Then we're going to take the whole assembly off. Once we have it out, we're going to take the safety box and take it apart, really, to see, to do the measurements and confirm the error code. It is indeed. Actually, so this is the part that we need to talk to, because something seems not okay in here. We're gonna strip to really check the relays. Put it there, and let's so we want to prove that whatever the diagnostic machine was saying, which was reading from this control unit, it is indeed wrong in this unit, because this is reading what this does. And we're going to take it apart and measure inside. Let's go, Didi. Let's detach it first of all. Okay, so we're going to put this on a side for now, because here where we need to work on. Put it once. Can you hold it? Fiddly. Can you bring another screwdriver? Hold on. And here is where the magic happens. So what we see in here, this is a pre-charge resistor, the relay for it, one of the main relays, and the second one should be just under. So we need to strip a little bit to really get to where we need to be in order to do our checks. So let's take these boards together out. Now this is how the relay box looked like when it's stripped apart, and we have a problem with one of those big relays. Those are the one that they are making close contact or opening contact on the high voltage cables, high voltage current cables. Now, one of them is in close contact, and is a simple test that we can do. The resistance check. Basically, we need to have what is called here on the multimeter open loop. So whenever we check those contacts, they have to be open loop. One that shows resistance is a faulty. Now, we already know, but I just want to show you for the argument's sake. So this is open loop, and this is our contactor, which is stacked. Now, those are not simple relay because obviously they have to control a very high voltage. Inside they have gas, inert gas, or thermal gas that helps to operate under such condition. It could also be hydrogen. Anyway, this has stuck contactors. Now, there are two ways to go about this issue. One, probably if you think about it, on the main dealer will replace the whole control unit, the whole safety box, and it's a good exercise. However, we've done quite a lot of repairs, and it's very rare when those relays are failing. And because we have used parts, I'm quite okay to replace just the relay and not the rest of it, because the components are still working. The car is not a very high mileage. And here we have another part, another box, safety box, which we stripped it, and we have the exact same relay. We obviously confirm from the safe part number because it's important that the specifications are the same. We are checking it and see the difference. So resistance versus open loop. Now, what we have to do, apart from changing the relay, is to replace the SME, the battery monitoring control unit, because some of error codes cannot be clear once they are stored. And we have two options of repair: obviously the whole safety box together with the battery control unit, or just the relay with the used one and the SME. What we're gonna do now, it's only going to be down to the customer. So I'm gonna inform him about the options, and he's gonna make the decision. Let's see what he says. Gonna make some phone calls. We have gone a bit backwards and forwards, try to find the best way to fix the BMW. And although we had a relay to replace the faulty one, this was the faulty one, yeah? Yes. Although we had a used one, which obviously not very expensive, but put everything in perspective, because this would also be a used one, and then on the module, on the safety box, it would be another relay and another components that could fail. The decision with the customer, it was to go for a new safety box that is just around 605, something like that, 500-600. Don't recall, but we'll see that at the end when we're gonna run through the cost. So we're gonna put those parts on the side, because in there we have the safety box. Didi, if you can take it out. So we won't put together this safety box, maybe with different occasion. We're gonna recondition, so we have a brand new unit from the dealer, obviously all the relays and warranty. Together with it, we're gonna have this battery control unit. We're gonna replace them both. Can you take it out? The reason to replace the battery control unit is that it stores a certain error code that cannot be cleared. So let's install the components on the bracket. It's interesting.
The old one has the markings.
Is it?
Yeah.
That's strange.
They
They do have. Okay. That's an interesting. So this looks is a brand new unit, definitely from the dealer, but it has like a pen marks on it. Anyway, it definitely comes from the dealer and it's brand new. Which way does it come? Come this way. Yeah. Should be from the. Yeah, because this goes like that. Correct?
Yeah. So,
Yeah. Perfect. So once we attach the safety box to the bracket, we'll go inside the battery. We need the yeah. With the safety box together, let's get it to the high line, to the high voltage, to have the unit installed. Now, again, we have to climb inside the car. And we're gonna pull those. Okay. So hard to. Okay, so we are ready to secure the safety box inside. So this part is now done. We have the connectors to go on. Now is the time for the high voltage. It's not the best position to be in. Try to. Okay. That's done. Interlock. Yes, if you hold it like that, drop it a bit more. I think the other one we've done it from the top, didn't we?
Yeah.
Yeah. All good. Let's make sure the seal is in place. Can you see the seal in place, your end?
Yes, it's on place.
Yeah?
Yes.
Perfect. So if we have this done, yeah, all good. Everything is now connected. What we're going to do now, we're gonna secure the covering few bolts, connect the high voltage cable. We want to do the programming first, make sure that everything runs fine before we put everything back. Are they final?
Just have to tighten.
Okay. Just gonna connect the high voltage line, and we're ready to do the programming. Connect everything. Okay. Perfect, that's all in. The interlock, Didi? The magic connector, it's also on. We've got everything on. Let's bring the tool to do the programming and hopefully get the BMW running. And then,
Should I connect the negative before?
yes, of course. Very important. Need to connect the batteries before. We'll do the programming. Otherwise, it's going to be a bit difficult, isn't it? All done. Let's see if we have ignition. So currently, we still have error message related with the battery, which is normal because the battery control unit that we install is not programmed. So only afterwards, after the programming and when there are no error in the system. So basically, what is going to happen, that control unit is going to perform a check on the high voltage system, close and open the relays, and if it senses that this process is carried out successful without errors, then it will enable the functionality, the correct function of the high voltage system, and obviously of the DC-DC charger, which is responsible to charge the 12-volt battery. Until Didi comes, let's set up the power supply. So as we need to do the programming, we need to have stable voltage. On over 13 volts. Let me see. Perfect. Always red first. Yeah. Charger is on, stable 14.2 volts, ready for spark. It's a bit rusted in there. Yeah, that's what happens sometimes. The negative terminal is actually very rusted, and it was sparking when I've had the connector on. Very important to use a clean surface. We're gonna put some grease after it, so it protects that. Let's see. Yeah, it's good now. Didi behind me is gonna carry out the programming procedure, and he's gonna call me when he's done. Is that so? Yes. So he confirmed. So I'm just waiting for Didi's call to have the BMW started and 12-volt system charged. I'm not taking a no, yeah? Okay, let's see. Didi has told me the programming is done and we should have a running BMW. Let's see if that's the case. I'm already connected to see stats of the battery, and the battery looks actually very good. Obviously, It's not is low state of charge, but state of health very good, quite balanced. Now what we see here, 12.8. We want to start the engine and see if that increases to over 13.5 volts. I think it's going to be even more, so let's see. Perfect. It goes in 15. It's going to drop, yeah, it drops to 14. So we do have the 12-volt system operating now. One more test. We're going to plug in the charger to see if this operates. As usual, we want to see blue after yellow. We don't want to see red. So blue, yellow, and then blue if it's charging, and we know it's all good. Now we're gonna leave it on charge. In the meantime, Didi is gonna install everything at the back, and afterwards we're gonna take it in a drive test. But so far, so good. Having everything installed, we had the battery on charge overnight, and we are ready to go in a drive test with a full battery. Didi, can you unlock the vehicle, please, so I can take the charger out? So we should have pretty much a full battery on the car. So the charging process should be done. It was a slow charge overnight, but enough to charge the battery. Are you connected, Didi? Yeah? Perfect. So we are scanning in here. We're gonna see battery studs. And while it's communicating with it, let me get inside the car. So it shows the full battery. Very good. State of charge, state of health, balanced. Perfect. Sounds very good. Let's see with the ignition on. Ready. What sort of range do we have on electric? Not showing yet. 17 miles, which I think probably is right for the F series. And we are ready to go in a drive test. Having already, we're just going to proceed in a road test to test the functionality on the high voltage system. We haven't done any work on the battery, so we're not really going to test the range, but we can see the stats as the battery state of health is very good. So it's going to be just a drive test to make sure everything operates fine. I will see you soon. We're going to set it up on a full electric e-drive, maximum e-drive, and then we have the mileage counted to 0, just so we use the electric drive as much as possible, so we can test the electric system. Morning. I just need to make a bit of room. It's a bit tight, our access here, and it's a very a busy morning as it seems. So far all the stats are looking good. Electric drive is operating fine, no error. Battery looks good. Let's put about 15 miles. If we manage to get, we never done a range test on a X5, did we? No, we haven't. So let's see what an X5 can do. Range wise, battery looks very good. So F15, good state of charge. I look 112,000 miles and the state of charge 100%. So the battery was kept very well. So this data here is very important for the battery operation. So the temperature in the battery should range between 20 and 40 degrees to make it operate optimal temperature, optimal condition. Having the battery operates on higher temperature is gonna degrade the battery, and over time it's gonna lose capacity, it's gonna lose state of health. So basically state of health is actually how much the battery has lost capacity. But this battery looks very good, 112,000 miles. So if you think about it, how old is this car? 17. Because you know, there's another question: how long does a battery last? Well, it's all depends on the maintenance. There are figures claiming about 10 years or 100,000 miles. I can definitely say it can go well beyond that, and this is a good example. So if now this battery reads 100% state of health, having maintained again simple things, you know, just have cooling, make sure no error codes on the car, not having charge with fast charge, because this is another aspect that it degrades the battery. It can last, definitely can last a lot. It's a Monday, no, Monday, what's this? Wednesday morning traffic, same as Monday. What's the busiest day? Monday? I don't know. Where you are, what's the busiest day for traffic in town? Or is there any particular day? So for the purpose of range test, try to emulate same condition every time. That's why we have windows fogging, because we don't want to use any consumers, so AC is turned off. We want to have electricity purely used for drive. So at the moment we've done 4.4 miles, we still shown 10 miles range, and we want to do this test because we haven't done an X5, an F15 range test. We want to see exactly what's the max that we can get out of the battery, a battery that shows 100% state of health, so it shows good capacity. We want to see what's the max that we can get with the optimal condition, so meaning not using the battery for anything else. And then outside is dry, so no rain, to use wiper and make more difficult the driving. So let's see, we're gonna find out probably in about 9 miles. So if we're gonna do 14 miles, I think this is about right, around 10 to 15, but probably a good battery is more towards 15. And the battery starts very good, well balanced. You can definitely say the battery is in good condition. And also another important aspect, we tend to do all the range tests for the batteries with 65 miles per hour, only because we want to set up a certain way of driving to compare the vehicles.
So we've done 11 miles, still shows about 2 miles. On the diagnostic machine, which still shows 24%, so a bit different information. But let's see until it comes to zero. But battery is still well balanced, an indication the battery is in very, very good condition. We have now completed about 12 miles, just getting up to 13. Range shows now 0. Still goes on electric. On the data we're reading, we still show about 10% charge. We really want to drive until the combustion engine is going to kick in, which probably is going to be any moment now. So we've got 13 miles. Let's see if we can squeeze another mile out of this battery. See if we reach 14. I think that's good. And then another important aspect that I haven't added in those optimal condition of driving, avoid sharp. Okay, so the engine just kicked in. We've got 13.6 miles on electric drive. Battery starts to look okay. So this is about how much you can get off an F15. If you have a different experience, please leave me a comment. If your X5 F15 makes more miles with a full battery, let me know what sort of condition and whether there's anything in particular if you do much more than 15 miles. But this is what we could get out of this X5, about 13.5 miles, and the battery looks in very good condition. So we're heading now back to the workshop where we're gonna do some final checks, and we are gonna have the stats about the cost of the repair, which is gonna be an interesting thing, I suppose, on top of the all technical information that we had so far. So let's talk when we get there. So we've done the final checks. Obviously we hadn't stripped components on the cooling side, but we've checked them all good, levels all okay, and the X5 is ready to go. But before that, let's recap what was the problem, how we fixed it, and more important, probably also an important aspect, what was the cost of the repair. So to recap, 12-volt battery was not charging. Run a scan. We've seen some issue in the high voltage battery. More precisely, one of the relays, we stripped the safety box, found one relay that was defective. We had to replace the SME. So that's the way that battery control unit looks like. It's quite a comprehensive piece of engineering, and this box over here controls the functionality of the high voltage system, of the electric drive, if you like. So we had to replace because one of the error codes is set on permanent and we could not clear it. Everything is done, but what was the cost of this repair? So initially we have to spend time investigating the problem, try to understand what went wrong, and for that we've charged 600 plus VAT. After we've concluded the problem, there were two ways to repair the car: to either replace the faulty relay, but that would have left us with second-hand components. And avenue that we've chosen after we talking with the customer was to replace the safety box, which was 573 pounds. So safety box in here, 573 plus VAT. The battery control unit, 314 plus VAT. And our labor cost to replace the components do the programming, obviously extensive road test that we did, it was 720 plus VAT. This is going to take us to a total of 2,200 plus VAT. And after we've done this test drive, we've concluded the system works fine, and we had a range of 13.5 miles on electric drive. So that's the way that the repair has been done. That's the range that we could get out of the battery on F15. So if you like this video, don't forget to subscribe to our channel, because we have often, actually weekly, probably twice a week, real situation with repairs from the workshop where we fix all sorts of cars, mainly electric and hybrid. So don't forget to subscribe, click the notification button, which way? This way, and stay close for more videos. I will see you soon.